This is Hallicrafters Rehabs. Welcome back. Actually, there was one thing I wanted to do with this radio. Let me turn the camera over a little bit so you can see. I've got the radio back, the case off of it. And the reason is because in band 4, you have the oscillator coil here, and you have the trimmer capacitor right here. And you can line it up with this on the low end of the band, but on the high end of the band, let's just say there's no longer enough capacitance to stretch out the band. And let me show you that on this diagram, what I'm talking about. In this design, and I'm sure in several, if not many other Hallicrafters general coverage receiver design. Basically, in the oscillator section, you have the oscillator tube plate coming through the switch, through a capacitance, to a resonance circuit here on this side of the coil, and then the grid is going to the mixer here on the other side. This particular capacitor does this. We'll just say this is a half moon dial, okay? And so this capacitor will take the electron, let's say that's the markings on there, but the actual signals, wherever it is where you have the main tuning condenser, move like this, slide like that. I wish I should have another color here. Imagine this is the electronic response, and that's what's on the dial. It makes it easier to tell. Okay. So by larger capacitances here, move the electronic response that way. Smaller capacitances there, move the electronic response that way. Then, when you're aligning the RF, this will have a slug in it. Okay, this moves the resonance on this side of the band. And this trimmer capacitor moves the resonance backwards and forwards on that side of the band. And essentially, this stretches the response or shrinks it, and this anchors the response where you want it to be. So this is fixed. It's in the factory. There's already a 7 picofarad high, stability capacitor right here, and an NP0 silver mica capacitor as a trimmer. However, on this end of the band, let's say this is where 30 should be. Well, that's where 30 is. Down here, I can anchor it at 14, 15, 16 like that pretty well. And it'll stay in pretty good agreement, but it's just not stretched enough. So, fix. It's trial and error. You try one and then you try another. Essentially, we're going to put another capacitor in here. I'm going to start with a 3 picofarad NP0 right here, and see if that gives me more stretch that way, and I can just do the adjustment I need to do. Probably not. I may have to go to a 5 or 7, and I don't have an NP0 in 5 or 7. I have a mica, so it will cause a little bit of drift in the high end, but that's okay. So that's the plan. we'll come back and get things. We're going to just, where I got to put it. Oh, here it is. Here's a little free picofarad NP0 capacitors. 4 kV, that should be enough, huh? And we'll just put that across tack it across the trimmer capacitor and see what happens. So, okay, well, success. After a little bitty failure, you don't want this to happen. But that's one of these dog bone ceramics. They're very delicate. That's 1,000 picofarads. And it's actually not as stable as one of these, which is the modern version, multi-layered ceramic capacitor, which is measured at exactly 1,000 instead of some approximate value. But that required me to go into this capacitance area for the oscillator, and to get it to actually tune right at 15 and 15, I ended up adding 330 picofarads plus this 1,000, plus the micro is 1,300, and there's 100 picofarad ceramic dog bone in there as well. But also on the upper end, I had to work on that. And we're not done. I had to work on the upper end by I basically replaced this, I don't know where it is now, but the silver mica, can't see it in the camera, but there's a silver mica trimmer, NP0, however, like so many of them, it's the silver mica has corroded, and so its capability has reduced. So I replaced it with one of my used stock that I got at the Hamfest one time with a whole box of them for like $15 or $20. Well, yeah, was that a deal? So this is in there, and I still had to add another 6 picofarad to that to get the top end to register accurately. I'm not going to go through that all right now. But it still wasn't working that well. And I forgot, there's one more thing you can do. You can modify the inductance of the coil itself. And to do that, I simply took this and ever so carefully took the top winding and separated it just a little bit. And that really did the trick. That it gave me, so this thing is already driven down halfway into the coil now. It was always all the way out before. So adding that little bit of inductance by moving that last turn, separating it just a little bit, gave me the margin I needed to register that. Now that probably affects registration across the dial in some respect, but it's 15 where I want it to be. 15 is a common shortwave band. People ought to do a lot of DXing on. So, and 17 will be fairly close. 13 will be fairly close. But, 13 megahertz shortwave band. So it's a little bit messy right now because I've been doing this. I haven't actually soldered the 300. It's just touching, wrapped around the thing. So I have to clean all that up a little bit. We'll be done with this, and it will be nicely working on band 4. The reason for that is I don't want to be, I want to be approximate on the dial when I'm tuning up the digital. It just, to me, what if this quits working? Where you're at. So we'll go with that. Turn this off and start cleaning this up tomorrow. I want to fasten this better to the back of the case. And actually, this will be a good time to fix the fact that the holes drilled in the bottom of the case don't match where the screws are. So you're like this, trying to get the screw turned inside there, and that's no good either. So we'll get that cleaned up too. Well, I've mounted all the new caps in with the oil side going towards the trimmer, which goes towards the ground. On the mica capacitor, everything's this 100 picofarad ceramic capacitor had no DC leakage, and neither did the mica. And so everything is good and ready to go in. And then, of course, I took the cap off and I have fixed the inductance. I think you can see it. There's about a 1/4 inch separation from here all the way around. To add that inductance to lower the frequency of it on the lower side of the band. So I put some coil dope. It's called, need to get some more. It's MG Chemicals Super Corona dope, and I use that a lot. I use it for dressing up capacitors and everything else because it's like 5,000 volts of breakdown voltage, and it's kind of like painting with clear plastic. But anyway, so that fixed the inductor in the new position, and you can break it loose if you need to change it sometime in the future. So I'll mount these in, and then we'll go from there. Okay, now everything is now nicely attached, and there's a close-up there of the coil and the trimmer capacitor there. That's about as good as focus as I can do with the camera still on the tripod for the macro lens. So all we have left to do here is put the slug back in. This slug was all the way out before I made this adjustment in the coil. And now, look at it, it's about halfway in. So all I'm doing is probably putting 1/4 inch between the top winding and the one below it, right in this area. Okay, let's see how it works. Everything's back together. Well, let's turn the volume down. It's much more cleaned up than I had planned. I didn't do the macro, but there is a new black lead here on this secondary to this coil. When I had it cleaned up and put back together, there was no margin again on the coil slug adjustment. So took this off and started adjusting a little bit more, and then broke a secondary lead. So I've taken out the coil and repaired that lead. It was just a simple break on the outside, easy to get to, and there's a little piece of shrink wrap black. I don't think you can really see it. Maybe if I highlight it. Anyway, took a little extra time, we'll say. But everything's back together and it's registering right on the money, all the way up and down the band, which was the end objective. Something to ponder this one. The inductor slug is mostly affecting this side of the band and almost nothing on this side. And the trimmer capacitor is affecting this side and almost nothing on that side. There's a little bit more influence of the inductor on this side than the trimmer is on that side. So you can speculate that on why that's the case. So I'm done with this. I want to drill out the bottom of the case. I'll have to show that to you, see what's going on. Okay, well, when I put this back together the first time, I went ahead and whited out where these holes really should be in order to have a straight in adjustment. Look how far that one is off. For the trimmers and the slugs. And I don't know, Hallicrafters, every single one I've ever worked on, I don't know, they must do their prototypes. And then they get to the point where and then they go out and they contract for the case to be cut and they specify the holes. And nobody ever goes back and, at least the next production run of these, they correct where those holes go. But they're always wrong. So I did it with Dremel the last time. I drilled and drilled and drilled and drilled and drilled. So I think I'm going to use just a high-speed drill and one of those notched things and just carefully cut those out, because it's not going to make any difference electronically, and it will make it a lot different in the ability to make adjustments. So I went ahead and painted it. These drill bits actually made pretty quick work of expanding the holes where they needed to be. Paint job wasn't that great, and it's inside the garage with the heater on, so we'll just let this dry overnight, and it's going to be buttoned up in the morning tomorrow. All right, so I've got the case back on. I don't have the screws in here in case there's some problem on the bottom. It's on the sides. And I went ahead and tweaked the first three bands a little bit just by looking at this and listening to the response as far as the RF and the antenna is concerned. So the bands are dead on as they can be analog wise, in agreement with the digital frequency display. However, in the middle of the bands, they're not exact. So if you get it perfect on each end, in the middle you might have a little variation, because who knows why. They painted, they made a model dial, and over the production run, it doesn't quite make it. So now let's go to band 4. And we're going to actually, this is But what I wanted to register for 14 should be right at 14. It's 1405. And I'm not going to tweak anything there. I am going to tweak right here in the RF. Might be some debris inside that. We'll have to check it out. Well, I think I know what it is. It's this mica trimmers that are not quite 100%. So we'll do a little bit here. On the low end of the band with these holes made larger, it sure is a lot easier. Okay. We'll go down to 30, which is about as high as you want it to be anyway. It's saying 30. It's not lit. 3903. Okay, so we'll adjust up here. Very touchy. I can actually get to this without twisting it sideways, upside down, and backwards with these holes cut out. Oh, so tiny adjustment. That is within the width of the white mark on the dial, right there. You can't really tell. There's really no point in doing any better than that. Let's see if this trimmer is giving us trouble. Well, my flashlight allows me to see what I'm looking at through the holes. I could use better reading glasses. It's the wrong one, that's why. There we go. Okay, then we'll go back down to 14. We'll check 15 on the way. Very nice. Okay. There's something going on in there. I'll check that out when I can turn it right side up. Let's check the antenna. Okay. And that's 1486. That's 14. And we're gun at 1405 if it's almost within the width of the white mark. So, all right. We'll flip her over, check out what's going on here. And so it was a little bit of blown dust debris inside that antenna compensator. And also, the RF in the antenna was not well adjusted, I guess because of all the work I'd done with the oscillator on band 4. So that all got ironed up. The motor booting's gone. It's pretty sensitive right now. So we'll turn this back over and then just check it out. Make sure there's nothing else going on. And then we'll send it inside the shack tomorrow. So, yeah, but it's working real good now. It's kind of funny. These came off of SX-99s. It's a facsimile, of course. It says, for your protection, this receiver has been properly adjusted and sealed at the factory. Breaking these without a written permission from the factory or dealer will void your RMA guarantee. Well, I think we're past that. So that's Trans World Radio from Swaziland, French. So after about breaking my arm, and I want you to know that transmitter weighs a ton. Actually, 80 pounds is beyond my ability to lift it. I did get it up there, but I may have to hire people to move that around when I get around to servicing it. So, but everything is where it's going to be, with the exception, of course, that the transmitter has not been gone through. And I have to get my amateur license for that anyway. So we'll get that done, and this will be complete in here. This is Hallicrafters Rehabs. Thanks for watching, and thanks for the new subscribers.